Hi everyone. In this video, we'll take a look at how we can compare different serverless frameworks. In doing so, we'll first take a stab at why you would want to use serverless frameworks in the first place, and some of the key attributes that a serverless framework would actually help us with. And that gives us some concrete idea as to why we would choose certain frameworks. Speaking of, in this video, I'm going to take a look at three different frameworks. One is the serverless framework, or serverless.com. And then we have Zappa, and finally we have another framework, which is AWS Chalice. Now, this by no means is an all-inclusive set of comparisons for all the various popular frameworks, but hopefully it's some of these are the popular frameworks that you would want to compare and contrast. So to get started, let's try and first address why we would want to use a framework for serverless applications. So serverless applications, obviously the new trend and very powerful in terms of capabilities. At the heart of serverless is this idea of the simplicity around function, and that's a function that you can deploy on a cloud-based infrastructure without having to pay for fixed infrastructure. So that's awesome. So in the world of AWS, it's really about things like Lambda functions and other services that support Lambda functions or tie into Lambda functions. But simple as it might seem, it can get a little difficult, and that's basically what a serverless framework tries to address. So let's start off with the first one. That's really about simplifying the whole process. And in looking at simplification, one of the key things that many of these serverless frameworks do is they provide some kind of an abstraction. And that abstraction tends to vary. So as with most good frameworks, it's really about finding that balance of abstraction. It takes the complexity away, but it does not sacrifice functionality and the underlying capability of the platform. So as an example, if you look at the kind of abstraction, so what many of these serverless frameworks gives you is, for example, they abstract away how the services are actually provisioned in the cloud. So not just the Lambda function or the function as a service, but also around various other storage, cloud monitoring, logging, and various other services, and it's completely abstracted away so that you just focus on the functionality of something like the Lambda function itself, as in case of AWS. The other thing that it normally abstracts is, we'll get into the details in a bit, but take for example, you have on your local environment or your existing production environment, you might have a solution that's based off of something like Flask for a web application or a REST API or even Django. And you're looking to migrate that over to a serverless capability. So that's an example of how a framework can hide away the details, but still allow you to deploy that solution without code changes or with very minimal code changes. So that's another example of abstraction. Finally, moving on to the other capability that we see across many of these serverless framework is this capability to do the provisioning and deployment. And I briefly talked about this in the previous topic around abstraction, but I think it deserves a lot more attention in itself. So again, let's think about it in the context of something like AWS. So in AWS, when you are deploying a Lambda function, you would, in most of these cases, if you're delivering it for purposes of something like a REST API, for example, you might, or even a web application, you would deploy AWS API gateway, and again, you might want to say, for example, if you want to trigger the Lambda function on a schedule, you will configure something like CloudWatch, or you might trigger it based off of some other event, like say, for example, a queue, an SQ, IoT kind of like applications or various others. So effectively, what we start seeing is Lambda is, or the function as a service, or Lambda in case of AWS is just one of the moving parts of the solution. But then there's quite a lot of other cloud-based services that needs to be provisioned. And traditionally, what used to happen is you have the the developers and the engineers focusing on Lambda and writing their core functionality in Lambda, and then handing it over to the DevOps team. And the DevOps team takes care of deploying all the other services around that Lambda function. Examples that we already talked about, like provisioning an S3 bucket or setting up AWS API gateway and various others. But then that's actually a handoff process that can take a lot of time, and it's not very optimal always for these teams to kind of like work with each other over prolonged periods of time. So also given the fact that in case of solutions like AWS Lambda, you only want to, or you really need to keep deploying these Lambda functions into the cloud fairly often. So a lot of your testing actually happens in the cloud. So it's not something that you will want to wait for a very lengthy deployment pipeline, like something like putting it in the hands of DevOps and then them delivering it through something like Jenkins, for example, for continuous delivery. You want a much faster way to deliver or deploy these solutions and not really have to worry about learning a lot of the infrastructure and DevOps tools, again, like CloudFormation or Terraform or even software configuration systems like Ansible or Chef or Puppet. You basically want to just focus on delivering the serverless solution and let the framework hopefully allow you to handle a lot of the complexities and abstract things away. So that's kind of like a nutshell around why you would use a serverless framework and kind of the reasons why you might want to assess different serverless frameworks. Speaking of which, in this video, we'll take a look at three popular serverless frameworks. We'll take a look at serverless itself, or serverless.com, the framework, and we'll take a look at Zappa, and finally AWS Chalice. So while these aren't necessarily an apples to apples comparison, effectively different serverless frameworks tend to have different strengths and tend to focus on different aspects of the serverless computing landscape. One might argue that it's not really an apples to apples comparison to look at these three in the same way. However, having said that, the intent of this video is only to provide you the right information or the information that I found in the journey doing serverless, and hopefully it gives you information that you can make a good decision on what is the framework that might suit you best. So for starters, let's take a look at some of the key strengths or key features of each of these frameworks. So starting off with serverless, I guess they're probably one of the most popular frameworks out there. And one of the major strengths is the fact that they tend to be platform neutral or cloud neutral in a manner of speaking. So they work with AWS, they work with Google Cloud, Azure, Microsoft Azure, and many others. So it's not a vendor lock-in or not very tied to AWS itself. So that's really a good thing. And the other thing to keep in mind is serverless is a general purpose serverless framework. So whether you're building web applications, REST API, or IoT kind of like applications using serverless technologies, it should allow you to work seamlessly. Zappa is another very popular framework, and I would say they were really the front runners for a lot of these serverless frameworks and the inspiration for many others. Now, their core strengths, while they can be used for various purposes, they tend to be very popular for web-based applications or even REST API-like solutions. And one of the key strengths was to focus around solutions like Python. And if you have a WSGI-based application, like again, if you're using Flask or Django, and you wanted to port that to serverless capability like AWS Lambda and AWS API Gateway, Zappa was the place to go. And then finally, we have solutions like AWS's native Chalice. While Chalice is relatively new in the market, they've kind of moved fairly quickly in the past couple of months. And again, like Zappa, they tend to be very, very focused around delivering web and REST API. Now, at this point in time, they're really only focusing on Python, and you don't have solutions for Node.js or various other languages, so it's very centric to Python. And it tends to follow the conventions of popular micro frameworks in Python like Flask, where it's really focused around specifying the URL routes and it mapping on to Lambda and AWS gateway. So I guess that's kind of how I would best describe the strengths and key features of each of these frameworks. Now, moving on to some of the key observations, challenges, and perhaps even limitations of some of these frameworks. With regard to serverless, the good thing about serverless is really the extent of their community and the existing framework and the wealth of capabilities that they have in the framework. It's by far none of the others seem to come close to the community and the overall breadth of the framework. However, it can also be challenging because a lot of what serverless does is it tries to abstract things away using their framework's configuration. It's like a domain-specific language or a DSL, and you'll find that if you've worked with other systems like, say, Terraform and with Ansible, there's a lot of parallels between how they've defined their DSLs and other popular provisioning and configuration management tools. So that's, I guess, one of the key challenges. But once you start using it, you'll find that you'll be right at home. But to begin with, it can be a little challenging. Zappa was probably the one that I had a love-hate relationship with, in part because while they provide a great abstraction for replatforming solutions which rely on things like Flask applications. Uh, as an example, if you have an existing Flask application and you use Zappa, it will through the abstraction kind of like allow you to use AWS Lambda, an API gateway without really having to change a lot of code. But you'll see in the examples later on, I'll show you some screenshots of how it might require still further debugging or changing of your code. So it's something that needs to be taken with a grain of salt. And the other challenge that I found with Zappa is that in comparison with serverless and in comparison with AWS Chalice, the actual deployment time it takes a lot longer. And typically deployment you wouldn't be so worried. But in case of AWS Lambda, you want to keep iterating really, really quickly. While most of the other frameworks tend to do it in a few seconds, the deployment I found Zappa to take the longest. But probably that's for smaller projects, it's taking a long time, and the others tend to kind of take longer perhaps for much larger projects. But regardless, it seemed to be very slow, and I found more numerous situations where I ran into errors and the provisioning I couldn't revert back, and I had to kind of like start from scratch. And then finally, in case of AWS Chalice, found that what they've effectively done is basically copy the URL routing of Flask and the kind of like deployment, kind of like commands or process that Zappa used, and kind of like lifted that model and embedded that into AWS Chalice. While that does bring a lot of simplicity, it really is not as elegant, mature, and complete as Flask. And there are certain prerequisites or folder structures that AWS Chalice needs, which basically means that you won't be able to take your, say, Flask applications and port that over to Chalice overnight. It's fairly straightforward if you have defined your AWS Flask application in a very structured way and not kind of like written your logic, say, all in one file, and instead if you've broken it down into multiple modules, it still becomes fairly easy to port that over to AWS Chalice. But I would say it's again an iterative process that you'll have to evaluate Chalice. So let's look at each of this in more detail. So starting off with serverless. The process in serverless is fairly simple. Here on the left-hand side is an example of a piece of code. This is in Python, and this is an example of what the Lambda function would look like. So here it's a very simple hello world example. So we are not doing anything much. So all it's doing is it's displaying a message anytime we invoke that function. So we have a Lambda function called hello. And it's actually, in this case, it's written in a file called handler.python, handler.py. And to connect it or to wire it all up, we have a YAML configuration file. And here we have defined a service called myService. And that's the service is what binds everything together in the form of a unit of deployment. And as we've discussed before, serverless is it works across different cloud providers. So here you can specify under provider that it's AWS, and specifics of the runtime, in this case is Python, and various other attributes of that provider. And then finally, we have the function here. And in the function, we are calling this function hello, and we are pointing it to this handler. That's handler.hello. So that's tying it to this piece of code here. We can specify the memory requirements and controller costs and various others. And more importantly, is if we didn't specify, let's say we didn't specify the section at all, it would have gone ahead and provisioned this Lambda function into AWS and would have stopped with that. But now that we have specified some events, and here we have specified that it's an HTTP, it will go ahead and, in addition to provisioning the Lambda function, it'll go ahead and provision AWS API gateway, and it will create an entry under get and point that to this handler. So that's really convenient. So in one shot, we can then go ahead and provision the Lambda function and also provision the API endpoint. In addition to that, obviously, we can specify various other parameters like passing environment variables, which you'll see in a screenshot in just a bit. Also, we talked about examples where if you were to wire up this Lambda function to an S3 bucket. This is an example of how you would do that. So as you can see behind, just by specifying your Lambda function and specifying your config in this kind of like a DSL, in this particular case is a YAML-based DSL, it makes provisioning fairly straightforward. So this is the world of development. And if you were to do some local development or testing, so again, if you may remember, we have this particular function here. If you wanted to test it locally, all you have to do is run serverless invoke local and the name of the function, and this would allow us to test the function locally. Obviously, it can be challenging for certain functionality, but for simple functions, you can test that function locally before actually having to deploy that to AWS. Now, the way that you would deploy this into an environment would be through running serverless deploy. And as you can see here, behind the scene, it does quite a lot of the heavy lifting for us. So we did not have to write anything like a CloudFormation template, or we did not have to provision the underlying infrastructure. It's all taken care of behind the scenes. So at the end of the provisioning, it will create a service based on your provider. And in our example, it was a very simple endpoint that would be provisioned through AWS API gateway, tying it to Lambda function, and that's basically it. So you can see that it's all provisioned fairly quickly if we do a serverless deploy. In terms of the components that are actually provisioned, while this might seem obvious at first, I'm explicitly pointing this because not all the frameworks behave in the same way. So as one would expect, because we have provisioned it through a serverless framework, it'll take our code, the function that we wrote, and deploy it as a Lambda function. So again, based on the language of your choice. So fairly straightforward here, and behind the scene, because we only had a get method, it would provision AWS API gateway, wire it all up, and then it would connect that endpoint to a Lambda function. In our case, it's a hello function. So that's basically what it would do behind the scene. In addition, it will also use AWS's CloudFormation to set up all the infrastructure and wire things up for us. So that's very convenient. However, if we take a much more complex example, ignore the code that I showed you earlier on, but imagine that you had a much more complex endpoint, which you needed to do get, post, delete, put, and various others. You can see that for each of The functions, we could map it to different verbs within our API endpoint. This again seems obvious at first, but only showing you because we are going to be comparing it with other frameworks. So that's serverless. Moving on to Zappa, and this is how Zappa works. So again, in this example, I've got a Flask application, a Python Flask application. So again, it's just a very simple REST API endpoint. So we've got an example such as this. We are using, you can use Flask or use Flask RESTful. In either case, that should work. And here all we are basically doing is creating these routes. So in our case, it's just adding a simple route, a hello world example. And we wire things up using a configuration. So the default is it'll create something called a dev. This is what's referred to as a stage. So you have a stage called dev. So like dev, staging, testing, UAT, prod, etc. You'll have different stages, and for each of these stage, you'll configure the various parameters here. So this is just a snapshot of some of the parameters. And the way you would deploy that is just run Zappa deploy, and then it would go ahead and provision all the underlying capabilities, the infrastructure needed. Again, behind the scenes, since Zappa is very focused around AWS, internally it does provision the services using AWS's CloudFormation. So here you can see that it actually packages your entire project as a zip and uploads that. Now this is where things start getting a little more involved when you're looking at Zappa. You remember in the previous slides I've shown you examples of how the serverless.com framework handles it, but in case of Zappa, even though we had only one endpoint, so here again we only had GET request, and notice here you'll find. All right, this is what it looks like when you deploy an endpoint using Zappa. Unlike what happened in case of serverless.com, you can see that in case of Zappa, it does not actually create different endpoints mapping to different HTTP verbs. It pops in everything into one single endpoint and then ties it into a Lambda function. You may remember that in our code we just have an example of a get verb. So we did not have a get, put, delete, and various others. But even if we had many of those, it would all bundle it into one single endpoint like what we have seen here, and call that into a Lambda function. And again, behind the scene, it uses CloudFormation to do that. If you try looking at the Lambda function itself within the AWS Web Console, you'll notice that it just ties it into a handler. That's a Lambda handler, but the code is too large, so it's been uploaded as a zip file. And if you try to look into the zip file, that could take a while to go through the entire code, but I'm just showing you key snippets. So this is what Zappa does, and it's both good and bad in my opinion. The good thing is it gives you that abstraction that you can kind of use a framework like Zappa, and it'll convert your code or wrap up your code so that all your existing say Flask endpoints just automatically starts working. But on the bad side is it abstracts things too much in my opinion. So behind the scene, the Lambda function that's being called refers to this file here. And as you can see from this file, you can see that that's quite dense with code, and somewhere at the very bottom you can find that within this code it actually has a class that has this method which is just routing it into, but you'll need to at some point get yourself familiar with how this is happening behind the scene, because it might work in some case, but before you put things into production or before you do some serious testing, you want to make sure that all your existing functionality is working. So again, it does require us to scan through some of this code and make sure things are working okay, do some bit of testing and various others. So that's, I guess, both the good and the bad about how Zappa basically works under the hood. And then finally, we have AWS Chalice. So AWS Chalice kind of tries to find a middle ground between the simplicity of frameworks like Flask and the level of detail that it ends up abstracting for us. So it's kind of takes the best, if you will, of Flask, but it doesn't require a lot of conversion or abstraction of our core functionality. So this is exactly how, for example, in your editor of your choice, if you have written a code in Python, this is exactly the code that you would use on your editor, and we'll take a look at how it gets deployed. But unlike Zappa, there's no abstraction. It basically is the code. The code that you have written is very much the code that gets deployed, and that's actually quite convenient. It simplifies the whole process. However, it's probably not very. It's not that straightforward migrating an existing application. Say if you have in Flask and you want to migrate that over to Chalice, it's not as simple as putting on a switch, if you will. However, again, if you have written your code well, and say, for example, your Flask application, you have created routes, but those routes are calling other libraries and modules and not doing the heavy lifting from within your application.python code, then that might be a lot easier to migrate to something like AWS Chalice. What I found Chalice to be really good at is the process of deployment. Probably it was one of the easiest because AWS Chalice just focuses around AWS. Obviously, it's an Amazon product, so there's less hoops to jump through, and it's really simple to deploy the solution. So just by typing AWS, I'm sorry, Chalice deploy, it provisions all the required capabilities for us. Again, Chalice is primarily focused on building web-based interfaces, both the web applications and REST API. It's not really a general purpose serverless framework, so it's very focused and does a fairly decent job of it. So that's how you would deploy it into AWS, and here you can see that it generates AWS gateway for us. And here you can see one of the other benefits of Chalice is it also has a way that you can develop locally. So just by typing in Chalice local, it kind of is similar to how Flask works, except that in case of Flask, if you are in debug mode, you have a nice debug server. So anytime you make changes to code, it automatically picks it up. But that's not necessarily true in case of Chalice, but still it's quite good to do your local development. So if you do Chalice local, it creates the service running locally, and then you can run, say, all your commands locally before then deploying it to AWS. And then finally, I'm kind of like wrapping it all up, or even before I do that, just a last point probably worthwhile emphasizing is even Chalice is similar to serverless.com. The REST API or the API gateway kind of like maps to the routes that you have defined. So here, for example, if you have created different routes and you have different methods for post, get, delete, etc., it maps it up very nicely. Finally, to sum it all up, we have looked at three different frameworks. Obviously, this is not a very exhaustive list, but gives you an idea of some of the key strengths, features, and key challenges when working with different frameworks. And while there's no one size fit all, obviously what we have in the market is lots of different open source projects or vendor specific products that tend to be focused on certain capabilities. So again, it would be good for you to do your own testing, evaluate it, do some POCs before you finalize on any given one framework. So again, this has been a really quick walkthrough of some of the very common frameworks, again, focused around building APIs and web interfaces. So hope you found this video helpful. See you on the next video. Thanks for watching.